find the y-intercept, the equation of the axis of symmetry, and the x-coordinate of the vertex. Make a table of values that include the vertex. Use the information to graph this. What is the vertex of that function? Go ahead, Isaac.
3, -1.
Excellent. So my vertex is 3, -1. Is the graph open up or down? Up. So in my xy table, it's x plus 3, y times 1 minus 1. So my new points are going to be at 3, 4, 5, 6, because 0 plus 1, 1 plus 1, or 1 plus 3, etc. And then here, 0 minus 1 is -1. 1 minus 1 is 0. 4 minus 1 is 3. And 9 minus 1 is 8. So using that information, my y-intercept, once I graph it, is at 0, 8. And again, you could have found that by plugging 0 in for x. 0 minus 3 was -3. -3 squared was 9. 9 minus 1 also gave you 8. So you could find the y-intercept algebraically or graphically. The AOS is the h value, or in this case, x equals 3. Looking at your graph, what are the x-intercepts? Looking at this graph, what are my x-intercepts? Got it, Isaac?
You want to do like 2, 0? Or,
Yep.
And then 4, 0?
Yep, so 2, 0 and 4, 0. If you look at your table, these points occur in the table when my YA plus K column has a 0. So the x-intercepts are another way of saying the solutions. The x-intercepts are also the solutions, and that's what we're going to talk about today. So solutions, or the x-intercepts of a quadratic equation. The solutions of a quadratic equation are called the roots. One way to find them is to find their zeros. The zeros occur when y is equal to 0. The zeros occur when y is equal to 0. And just to reiterate some vocab, the ax squared part is known as the quadratic term. The bx part is referred to as the linear term. And c is what we refer to as the constant term. In a quadratic, the highest exponent or degree can be 2. In order to be a quadratic, the highest exponent or degree is 2. When we talk about solving quadratics, we want to find the x value when y is equal to 0. These are the values when the graph crosses the x-axis. So as we just saw in the warm-up, these are also known as the x-intercepts. You will commonly hear x-intercept solution zeros and roots be used interchangeably. It's just the method with which you find them. The zeros or the x-intercepts come from the graph. The solutions or roots are quote-unquote found algebraically. There are 3 different types of solutions a quadratic could have. We have a case where there is no solution or no x-intercepts. This is where the graph is shifted up above the x-axis or reflected down and below. We could have a case where you get one solution. That is where the vertex is on the x-axis. This is also known as a repeated root. This is also known as a repeated root. Or we can have two solutions. So quadratic equations can have one, two, or no solution. If you're given a graph of a quadratic, the solutions are the points where the graph crosses the x-axis. So in this case, this graph is shifted down 4. My vertex is 0, -4. And the solutions, or the zeros, are at x equals 2 and x equals -2. If you're writing it out as the x-intercepts, we list them as ordered pairs. So that would be -2, 0 and +2, 0. In example 2, in standard form, this is -x² plus 2x, which means that the y-intercept is 0. The vertex comes from h and k, so h is -b divided by 2a. So we can see that the vertex x value is 1, the y value comes from plugging 1 in. So my vertex was at 1, 1. And again, if you apply the y-intercept and the vertex, you see that the graph goes down 1, right, left 1, which tells you the graph goes down 1 and right 1. In order to find the x-intercepts, we would graph until it crosses. In this case, it has now crossed, and it crosses at 0, 0 and 2, 0. Thus making my solutions x equals 0 and x equals 2. So again, as the intercepts, you list them as ordered pairs. As solutions, we list them as x equals and give the value. Well, what I expect for you is more like this. So like if this is in standard form, I'd want to know, do you understand what the y-intercept is? So that's 0, c, so in this case 0, 8. What's the vertex? So you would need to find h. which is negative b divided by 2a. So then you would plot negative 3, negative 1. And then you would need to make your table with like your x plus h, ya plus k. So you could plot your points until you see the intercepts. So in this case, I do like negative 3, negative 1, negative 2, 0, which means my other root, one root is at negative 2, and the other root is at negative 4. And then you could plot your fifth point by counting up and over. I'm off one. So this goes up and over 3, so you could go up and over 3 as well. Because when you're graphing, I just need 5 points. So if you find the y-intercept, you can plot its symmetric point, you can plot your x-intercept symmetric points, and your vertex. Your homework is the page in your packet labeled as homework. So, I know we didn't finish the notes, but that shouldn't affect your homework.
Is it this too?
It's the front and back. No. It says like homework. It's just the front and back. So like
That's just a back.
flip. Okay, it's 14 and 19, and then the 4 graphs.
Okay.
Because 14 and 19, you're just telling me how many solutions based off that, and then the 4 graphs you're graphing. I forgot this page was like. Thank you. I should have put a blank page. It messed up all my copies when I made the outline, and I didn't put a blank back to it. So instead of everything being like a normal front, back, it's like off. Because I didn't put a blank sheet of paper when I made the outline page. Usually I do the outline in a blank back.
Oh, you put it on.
But I did an outline and then the notes on the
So
back.
now everything's off.
Yes.
The homework is like on front.
Yes.
Yeah.
And it's and I was like, oh, I already made